So let's go over another example for you. As usual, we're going to start by writing a review for you, markers, and then a multivariable function. Again, all of these contents are like chain connected together. You need to review the materials that you learned before to be able to analyze these new functions. Very good. So review example. Not this marker. Let's do this one. Next. Suppose I give you y equals to ln of x. Okay, ln of x. What's the domain of this function? Well, as you remember the graph of ln, natural log, the graph of ln of x behaves like this. All right, well, it means that it starts from 0 but doesn't include 0. And then it goes to positive infinity on x-axis. So the domain is equal to the set of all x values such that this quantity, whatever it is larger than 0. So in general, if you have ln of a quantity, to find the domain is equal to all x values such that that quantity, including x, is larger than 0. Okay, so let's make it more interesting. What if I give you something like this? Here we only have one free variable, y depends on x. Now I'm going to create a two-variable function. Suppose y is equal to ln of, let's follow the notes. Here we have y squared minus x. Okay, y squared minus x. And this is z. So z is equal to ln of y squared minus x. It means that, hey, we have a two-variable function. Here we have two free variables. Let's find the domain. What is the domain of the function? Well. Remember the definition. Always follow the definition. By definition, they have the following. The domain is equal to the set of all points or their pairs, x, comma, y's, such that, well, they're satisfying some conditions. What condition? You have ln of a quantity. It doesn't matter what that quantity is, that quantity must be larger than 0. Y squared minus x must be larger than 0. So the domain is the set of all points in the plane, xy plane, such that there is a relation between x and y. Y squared minus x is always positive. But what is this? How do I visualize this inequality? Again, going back to algebra. What we learned in algebra before. In algebra, you have y squared equals to x. Okay. Well, it's different from y equals to x squared, guys. Y equals to x squared gives you a parabola. Here you have y squared equals to x. You can say that, hey, y is equal to plus minus square root of x. If you want to take the square root of both sides, guys, make sure to add plus minus sign as well here. right? So let's graph this using the same line. This is plus square root, and this is minus square root. Okay, should I shade right-hand side or left-hand side? Well, here you can use some checkpoints. You can take some points like, for example, 1 and 0. 1 and 0. 0 minus 1 is -1. It's not larger than 0. You can use a checkpoint. So since 1 and 0 doesn't satisfy this inequality, we're going to shade left-hand side. And since there is no equality involved, you're going to use a dashed graph. So this is the domain of this function. This is your domain. All of these points on the left-hand side of this curve are going to be the domain of this function. Guys, again, I am not visualizing Z. I'm just analyzing the domain of this function. It's easy to visualize two-dimensional objects like this, but when it comes to a three-dimensional object, three-dimensional surface, we prefer to use some online nice resources. Now let's take a look at our website. So suppose here we have ln of the function y squared minus x. Well, this is the object in 3 dimensions, guys. And as you can see, if you look at the shaded area, you can check the domain. We already graphed the domain on the whiteboard here for you. Here we have a 3D visualization of our expectation.